Hello everyone, welcome to the Module 2 of Climate Change course. So in previous module, you have learned about the component of the Earth climate system and some introductory about the interaction among those components, which is an important factor that govern our global climate. So in this module, we will try to understand about the process that drive those interactions and also govern the global and regional climate of the Earth. So basically, in this lesson, we will learn about the sun energy, which is the power supply for the Earth climate system, and the factor that influence its distribution around the Earth. Then we also learn about the greenhouse gas and its greenhouse effect, which help to keep the Earth's surface temperature warm. And lastly, we will also learn about the factors that affect the global and regional climate pattern, including the atmospheric circulation and the ocean circulation. So by the end of this lesson, you should be able to first explain how the solar energy flows throughout the Earth system and how the greenhouse effect works. Then you should also be able to identify the important factors that shape the global and regional climate pattern. And you should also be able to describe the process of the atmospheric and ocean circulation and their impact on the climate system. So before we begin to explore the process that govern our global climate, it is important to recall that the climate system is made up of 5 major components, including the atmosphere, which is the mixture of gases about the Earth's surface, and the hydrosphere, which refer to the all of the liquid part of the water system, such as the ocean, river, and lake, and also rainwater. And then the cryosphere, which includes all part of the frozen water system, including sea ice, land ice, and also all type of snow cover and frozen soils. And the lithosphere, that includes all the material of the Earth crust and all type of topographic characteristic. And also the biosphere, which includes places that life exists, and also all the living organisms, including human beings. So this 5 component of the Earth climate system is continuously changing and interacting with each other to maintain the Earth energy balance and making the Earth an inhabitable place for us. It is also important to remember that the sun is the only source of energy that powers the Earth system. Without the light energy that is radiated by the sun, the Earth would be just a dead planet without life. But how much the amount of sun energy reaches the Earth's surface and how it is redistributed across the Earth system can significantly influence our global climate condition. And it is determined by the characteristic of individual component of the Earth climate system. So now let's talk about the distribution of the sun energy and energy balance within the Earth system. As mentioned earlier, the sun plays a very crucial role on the Earth climate process because it is the only power supply for the climate system. How much the amount of sun energy reaches the Earth's surface and how it is redistributed across the Earth system is strongly influenced by the characteristic of the component of the Earth climate system. The energy from the sun arrives at the top of the Earth's atmosphere as UV or visible light. It can pass through the atmosphere across a layer of gases, but not everything can reach the ground. So in general, about 50% of the energy from the sun is absorbed, reflected, and scattered by the atmosphere. So only about 50% can make their way to the ground. So the amount of energy that scattering of light energy occur when light strikes particles, atmospheric gases, water droplets, or dust which cause them to fly away from point of contact in all directions. And reflection, on the other hand, occur when light bounces back to space as it encounters with the surface material. The rate of reflection depends on the characteristic of the surface that it encounters. Generally, black and raw surfaces have much lower albedo, so they reflect very little light. But white and smooth surfaces have very high albedo. They can reflect significant amount of energy back to space. Okay, now let's discuss about the greenhouse gas and greenhouse effect. So the process that greenhouse gas in the atmosphere trap heat energy which is emitted by the Earth's surface is called the greenhouse effect. This process is very important in keeping the Earth temperature warm. Without this warming effect of the greenhouse gas, the Earth would be deadly cold. The Earth temperature would be extremely variable, just like the moon temperature, which is boiling hot at the daytime and freezing at night. So thanks to the greenhouse effect that keep our Earth average temperature moderate, so we can survive and other species can also flourish. The level of greenhouse gas in the atmosphere can have direct impact on the atmospheric temperature. If the concentration of greenhouse gas in the atmosphere increase, the Earth's surface temperature would also increase. In contrast, if the greenhouse gas concentration is lower, the Earth's temperature will also become lower. The influence of each gases on the Earth's atmospheric temperature depend on both its global warming potential and the amount of gases that enter the atmosphere. For example, for carbon dioxide, it has the smallest global warming potential, but it is listed as the more important greenhouse gas in the atmosphere because its emission in the atmosphere is very high. On the other hand, although the emission rate of the nitrogen 3 fluoride is very low, it is still considered as an important greenhouse gas that can govern the Earth's temperature, as it has very high global warming potential. The amount of heat trapped by greenhouse gas in the atmosphere depends not only on the concentration of gases, but also depends on its types. Because each type of gases has its own chemical characteristic, it also has its own heat trapping ability, which together with the duration that it could stay in the atmosphere is called the global warming potential. The gas that stay longer in the atmosphere has higher global warming potential than those gases that can stay in relatively shorter period. So showing in this table are the important greenhouse gases listed under the Kyoto Protocol as the gas that significantly influence our Earth climate. This consists of natural greenhouse gas such as carbon dioxide, methane, and nitrous oxide, and also the man-made greenhouse gas including the hydrofluorocarbon, perfluorocarbon, sulfur hexafluoride, and also nitrogen 3 fluoride, and also nitrogen 3 fluoride. So now you have already learned that our Earth climate is powered by the sun energy, and that the characteristic of the climate system component is the factor that keep the Earth energy budget balanced and govern the global climate. So how about the regional climate pattern? So I believe everyone knows that not everywhere around the Earth have the same climate condition. So in fact, the Earth climate is divided into 5 major climate zones, including the tropical, dry, moderate, continental, and the polar climate zone. So the area that located in each of these 5 climate zones generally share the similar climate characteristic and also found in the same latitude. The tropical climate zone is divided into the subtropical wet and tropical wet and dry. The tropical wet is characterized by constant temperature of about 27 degrees Celsius, with relatively high temperature, and these subclimate zones are generally found in the Central America, Africa, and some part of Southwest Asia. The tropical wet and dry subregion has a rainy season and dry season. Air temperature is generally cooler in the dry season and warmer in the wet season. This climate zone is found next to the tropical wet in America, Africa, and some part of Southwest Asia. The continental climate zone is divided into the humid continental and the subarctic subregion. The humid continental is characterized by a great variety in temperature and precipitation. The weather in this climate zone is divided in 4 seasons. However, the length of each season is vary according to the latitude. This subregion is generally found in the mid-latitude interior of the northern hemisphere. The subarctic region is defined by a huge temperature variation between summer and winter. Summer is generally very short and cold, while winter is very cold and extended. These subregions are found in northern of Canada and Russia. Then the last climate zone is the polar zone. The polar climate zone is divided into the tundra and ice-capped subregion. The tundra subregion is defined by a very cold temperature, low precipitation, and frozen ground. It is found in the northern hemisphere around the Arctic Ocean. The ice-capped subregion is characterized by snow, ice, and permanent freezing temperature. It is found in polar region on the both. The ice-capped subregion is characterized by snow, ice, and permanently freezing temperature. It is found in the polar region on both the North and the South Pole. The highland climatic zone is generally cannot be specific. The highland climate is vary with latitude, elevation. So we can see that the world climate is divided into various climate zones located in different latitudes of the Earth, which create a clear regional pattern. The factors that shape such a regional pattern are the distribution and flow of the heat energy around the Earth, which is mainly governed by the movement of the air in the atmosphere, or collectively we can call the atmospheric circulation, and the movement of the ocean current, or we can call it ocean circulation, and the interaction between these two factors. The atmospheric circulation is defined by major movement of the air in the atmosphere, which create different wind pattern or wind belt in different latitudes of the Earth. It is very important in shaping regional pattern of the Earth climate because how the wind is blowing around the Earth strongly affect the distribution of the Earth's surface temperature. The ocean circulation is a large-scale movement of water across ocean basin. It can potentially affect the regional climate pattern as it cool or warm air temperature above the sea surface. Its effect on the regional climate depends on how far the region is from the ocean. Generally, the region that is closer to the ocean receive more influence than the other region that located farther. And in addition to the effect of ocean circulation and atmospheric circulation, there are also other factors that can affect on the regional climate. This includes the characteristic of the Earth's surface, such as topographic feature, whether the area is a low-lying or a highland, and the surface albedo, which depends on the type of surface cover, whether the area is covered by vegetation, by ice, by rock, water, or just bare land. So we will talk about all these factors in the next few slides. Okay, so let's start with the effect of location, why location is matter, and why we have different climate zones in different latitudes. Well, this is because we receive different amount of sun energy at different latitudes. So although the heat budget of the entire globe is fairly balanced, it is quite different from one location to another location. And there are three factors that lead to such an imbalance. First, the amount of sun energy reaching the Earth's surface is more concentrated in the equator compared to the higher latitude and polar region. This is because the Earth is spherical, so its surface is curvature. So although the sun sends the same amount of energy toward the Earth at every latitude, how much energy the Earth's surface is, or how much energy reach the Earth's surface is not equal everywhere. In general, at the equator, the sun rays travel straight to the Earth, so the amount of energy is concentrated over a small coverage area. But at the higher latitude and the polar region, the same amount of sun energy reaches the Earth's surface at certain angle, which makes it to spread over a large coverage area and become less concentrated compared to that in the equator. This is somewhat similar to the sun energy during the morning and evening time. So when the sun is at the angle above us, the sunlight is not as strong as it is in the afternoon when the sun is straight above our head. Another reason is because the Earth is tilted. The polar region receives no sunlight during winter time, while at the equator, sunlight is available every day for the whole year. And the last reason is the polar region are often covered with ice and snow, which has very high albedo, so it reflects most of the incoming solar energy back into the atmosphere and leaving very little amount of energy on the ground. So these three factors are the main cause that led to the imbalance of heat energy between the low and high latitude of the Earth, and it is what drives the atmospheric circulation that influence the regional climate patterns. So now let's talk about the atmospheric circulation. So just like water molecule, the gas in the atmosphere or the air is always moving. The global movement of those air mass is called atmospheric circulation, which is governed by three factors, including the temperature gradient, pressure gradient, and the effect of Earth rotation. The temperature gradient is the differences in air temperature between two locations, normally between the air at the ground level and at higher altitude. These differences in temperature cause air mass to exchange between warm and cool area in order to maintain heat energy balance. So similarly, the pressure gradient is the differences in air pressure between two locations. It causes the air to move from high pressure zone to low pressure zone horizontally from north to south or from south to north. However, due to the Coriolis effect of the Earth rotation, this north-south or south-north direction is deflected to the west or to the east to create the westerly wind and easterly wind. The vertical and horizontal movement of the air together create the convection cell that define different weather zone. This includes the Hadley cell, Ferrier cell, and polar cell. So the Hadley cell is located between 30 degrees north and 30 degrees south. This cell is said to be thermally direct because warm air is rising and cool air is going down to the Earth's surface. So particularly in the Hadley cell, the sun heats up the air along the equator region, making the air at the equator at ground level become warmer than at the layer above it. This creates the temperature gradient between ground level air temperature and air temperature at the higher latitude. So because warm air is lighter, it begins to rise and moving up until it reaches the top of the troposphere, where the temperature gradient is no longer significant. It starts to deflate toward the North Pole and South Pole and keep moving until it reaches about 30 degrees north and 30 degrees south, where it's become cooler and heavier enough. It begins to sink and go back to the Earth's surface, creating the high pressure zone at the ground. So once it reaches the Earth's surface, it starts to deflect or moving back to the equator region to complete the convection cell. So the Farrell cell located between 30 degree and 60 degree south and 30 degree and 60 degree north. These cells are said to be thermally indirect. So in this cell, the air at the ground level at 30 degree north and south is in the high pressure zone. It is pushed to move away from the area toward the polar regions. However, when it reaches about 60 degree altitude, it encounters with the cold air current that blow from the polar area. So the effect of pressure gradient is no longer significant. The air starts to move upward to the troposphere, and once it reaches the top of the troposphere, it begins to deflect and move back to the equator region. And at around 30 degree north and south, it encounters with the warm air current that blow from the equator area. Then it starts to deflect and move back to the ground and repeated the cycle over and over again. So the polar cell located between 60 degree north to 90 degree north and between 60 degree south to 90 degree south. This cell is thermally direct. In this cell, air rise at around 60 degree north and 60 degree south and sink at the north and south poles due to temperature gradient. And horizontally, air moves from both pole regions toward the equator, but due to the Coriolis effect of the Earth's rotation, this horizontal direction is deflected to the west, which creates the easterly wind in this convection cell. So in summary, we can see that the temperature gradient, pressure gradient, and Coriolis effect are the major factors that influence atmospheric circulation, which create different wind patterns and influence the global climate pattern. The three convection cells set the framework for a regional climate. And in general, where the air is rising or sinking at the equator at 30 degree north, 30 degree south, 60 degree north, 60 degree south, and at both polar area, there is very little wind because the horizontal air movement in this region is not significant. And in addition, because warm air can hold more moisture than cool air, at the location where the air rises, including the equator and 60 degree latitude, there is generally high level of precipitation compared to other regions. Okay, so now let's talk about the ocean circulation. Ocean circulation is the large-scale movement of water in the ocean basin. It can greatly affect on the Earth climate system because unlike the land area, which can store heat energy only on the surface, the ocean can store heat energy at greater depth. So in that sense, the ocean can store a large amount of heat energy. And as the ocean water is moving around the Earth, it transports with it a large amount of heat energy. And this energy transport by ocean current can significantly affect on the regional climate by making the air temperature above the sea surface warmer or cooler, which consequently affect on the condition of climate of the nearby region. Now let's take a look at the global ocean current. Actually, large-scale movement of ocean current occur both at the surface and at the deep sea. Somehow, this map illustrates mainly the major direction of surface ocean current. So if you remember the direction of wind blowing in the convection cell, you will be able to tell that ocean surface current travel in the same direction as the major wind belt. This is because this surface current is driven by the effect of wind blowing. So for instance, in the Indian Ocean, the westerly wind pushes the water in the southern part of the ocean to move from west to the east. And once this water runs into the continent, due to Coriolis effect, it deflects and moves toward the equator. And once they reach the equator, trade wind pushes them to move back to the west until they approach the continental landmass. They deflect to the left and move toward South Pole under the Coriolis effect again. So this movement form a giant loop water current, which is called the gyres. So the same phenomenon also happen in the North and South Atlantic Ocean and also North and South Pacific Ocean, which create 4 other gyres that rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. These gyres play an important role in governing local and global climate because as they transport heat energy from equator to the polar region and bring back cold water current from pole back to the equator, they also cool and warm the air along the way. Furthermore, besides influencing on the air temperature, ocean current also affect the precipitation level. This is because warm water current bring more moisture, thus it also bring more rain to the region than the cold current do. In addition to the surface current, the motion of ocean water also distribute heat energy from surface water into the deep ocean through a process called the thermohaline circulation, which is driven by density gradient that depend on water temperature and salinity. Basically, in the North Atlantic Ocean, sea ice formation remove the fresh water and leave behind water that is very saline and very cold. This saline and cold water is dense, therefore it sinks to the bottom. Then after sinking, they flow to the south and circulate through the deep sea until it rises to the surface at various locations. They then return to the North Atlantic Ocean in the form of surface current. This combination between the thermohaline circulation and surface current form a global ocean current which is known as the Great Ocean Conveyor Belt. This Great Ocean Conveyor Belt brings warm surface water to the north and push cold deep water to the south to balance heat energy in major ocean basins and act as the regional climate moderator. Aside from the effect of ocean current, how far the region is from the ocean is also greatly affect its climate. Because land material has lower specific heat capacity, which is the amount of heat required to change temperature of 1 gram of substance by 1 degree Celsius compared to water, land area generally absorb and release heat energy more easily than water, which make air temperature above the land much more variable compared to the air temperature above the ocean. So due to this reason, we tend to experience a great deal of temperature variation in the region far away from the ocean, and we tend to have quite stable weather pattern in the coastal region. So in addition to the effect of atmospheric circulation and ocean circulation, the other factor that affect the regional climate is the surface characteristic of the region, which include the altitude and surface albedo. The altitude affects the climate of the region because air temperature decreases with height above sea level. The region with higher altitude tend to have cooler weather compared to the lower area. This is why we generally have cooler weather at the mountainous region compared to the lowland area. And similarly, surface albedo, which is characterized by type of surface cover, also affect climate locally and globally because different types of surface cover have different albedo, so they reflect the sunlight differently. So as you can see in the table, snow and ice have very high albedo. It reflects about 90 to 80% of the incoming solar radiation. This is why we generally have cool weather in the area that is covered by ice and snow. The presence of ice and snow affects not only the local and regional climate, but it also has the potential to cause global climate variability. For example, if the land ice is melted, the swarm that replaces it will have much lower albedo. So more heat will be absorbed, which causes local weather to become warmer and consequently alter the atmospheric circulation and affect the global climate. So now we have reached the end of Module 2. And until this point, there are some important things that you should take as the take-home message. First, you should take note that our climate system is powered by the sun energy. How the sun energy is distributed around the Earth is the main reason that we have different climate patterns over different locations. Then you should also remember that the local and regional climate is influenced by the location of the region, including its latitude and proximity to the sea, and also influenced by the surface characteristics such as topography and surface albedo. In addition, you should also remember that atmospheric circulation and ocean circulation are the major factors that govern regional climate. So while the atmospheric circulation drives regional wind pattern, ocean circulation acts as the regional climate moderator. And more importantly, because our climate system is an interactive system, a small change in any feature of the system will result in climate variation, either it is locally or globally. So now we can call it a day and we will meet again in the next module.